In this video, I'm going to cover section 9.1, the metric system, from Contemporary Mathematics, from OpenStax. Section 9.1's learning objectives are the following. Identify units of measurement in the metric system and their uses, order the 6 common prefixes of the metric system, and convert between like unit values. Whether you're traveling, baking, watching an international sporting event, working with machine tools, or using scientific equipment, it's important to understand the metric system, or the International System of Units, SI. The metric system is a decimal measuring system that uses meters, liters, and grams to quantify length, capacity, and mass. It's used in all but 3 countries in the world, including the United States. Units of measurement provide common standards so that regardless of where or when an object or substance is measured, the results are consistent. Distance can be measured in feet, meters, or miles. Weight, for example, can be measured in pounds or grams. Volume, or capacity, can be measured in units such as gallons or liters. The metric unit for distance is the meter. It has the symbol m. A person's height might be written as 1.8 meters, or 1.8 m. A meter is slightly longer than a yard, which is about 3 feet, while a centimeter is slightly less than half of an inch. The metric unit for area is the square meter, or m squared. The area of a professional soccer field is 7,140 square meters. The metric base unit for volume is the cubic meter, m cubed. However, the liter, which is a metric unit of capacity, is used to describe the volume of liquids. Soda is often sold in 2-liter bottles, or 2L. The gram is a metric unit of mass, but is commonly used to express weight. The weight of a paper clip is approximately 1 gram. And the metric unit for temperature is degrees Celsius. The temperature on a warm sunny day might be about 24 degrees Celsius. Let's look at this example. Which base unit would be used to express the following? The amount of water in a swimming pool, the length of an electrical wire, or the weight of 1 serving of peanuts. For number 1, we're talking about volume or capacity, so generally we would want to express this in liters. For 2, we're talking about the length of something, so we want to measure that in meters. And for the weight of a serving of peanuts, we're talking about volume or capacity, we're talking about weight, so we would want to measure that in grams. The metric system has prefixes, which are letters that go at the beginning of a word to denote kind of the size of something. So here we have 1, 2, 3, 4, 5, 6 different prefixes, starting with their abbreviation. So we'll talk about the prefixes. You have kilo, hecto, and deca. Base units are not prefixes. This is your meters, liters, and grams. So we can write like right here, meters, liters, and grams. So these are your base units. And then deci, centi, and milli. So each of these prefixes correspond to a power of 10. So for example, when we talk about magnitude, 10 to the third is 1,000. So we're talking about 1,000. So 1 kilogram would be 1,000 grams. A hecto is 100. A deca is 10. This is 1. This is 0.1, or a tenth is another way to write that. This is 0.01, or 100th. And then here we have 0.001, which would be 1,000ths. And so what we talk about this is, well, these are what we're going to talk about as our conversion factors. We'll get to that in a minute. But just to show you that we're talking about magnitude when we talk about these prefixes. So for example, what is the order from smallest to largest of centimeters, millimeters, and decimeters? So the smallest, so maybe I would think it would be nice to kind of label. So we've got centi here. So remember, centi is 10 to the negative 2. And here we have milli. And milli was 10 to the negative 3. And we've got, so made a mistake. Centi is 10 to the negative 1. Because deci is 10 to the negative 2. And so the way I kind of help myself remember this is, the way I learned it is keep her dancing because dancing creates marriages. And I was actually right the first time. I should have kept with my gut. I'm sorry. That's why I write it out. So centi is 10 to the negative 2, as I said. And deci is 10 to the negative 1. And so keep her dancing because dancing creates marriages, or there's other ones that you can remember. But this kind of tells you from left to right, largest to smallest. And so here we can see, based on their magnitudes, that deci, we want the smallest to largest. So smallest is going to be milli. So a millimeter. And then a centimeter. And then our decimeter. And just to show you, the way that we would shorthand this is it would be mm for millimeter, it would be cm for centimeter, and dm for a decimeter. And so those would be from smallest to largest, because this would be 0.001, this would be 0.01, and this would just be 0.1. That would be smallest to largest. So how do we convert between those? We have something called conversion factors, and those are used to convert from smaller metric units to larger metric units and vice versa. It's a number that, when used with multiplication or division, converts from one metric unit to another, both having the same base unit. So we only convert from kilograms to grams or grams to milligrams, so forth and so on. In the metric system, those conversion factors are directly related to the powers of 10, which is really nice. Everything is base 10 in the metric. Alright, so let's look at an example where we convert metric distance using multiplication. So in this example, the firehouse is 13.45 kilometers from the library. How many meters is it from the firehouse to the library? So we're going to start with 13.45 kilometers. So 13.45, we can also pronounce this kilometers. Kilometers and kilometers are basically the same thing. So when I do this conversion factor, I like to draw this little table, and it helps me. So up here in the top left, we always start with what we're converting from. So we're going from kilometers to meters. And then, because we want to get rid of kilometers, that's going to go in the bottom. So we've got kilometers down here. And then we want to end with our units in meters, so that's going to go up top. So 1 kilometer is 1,000 meters. So we've got this as our conversion. 1,000 is our conversion factor. So we're saying 13.5, and in this table what we're doing is multiplying if they're on the top and dividing if they're in the bottom. All right, so we're going to do 13.45 kilometers times 1,000 meters per kilometer. So what ends up happening is, because kilometers is in top and bottom, they cancel, and then we do 13.45 times 1,000. So that results in 13,450. Another way we could think about doing this is, because anytime we multiply by a factor of 10 or a power of 10, what we're really doing is just moving this decimal place once to the right. So multiplying by 1,000 is basically taking this decimal and going 1, 2, 3 places, and any time you have a blank space, 0 is our space placeholder. And so that's how we got, same thing as 13,450, and this is meters, so it would be an M, or we could spell out the word meters. So that's how we convert 13.45 kilometers to meters, is either by multiplying by 1,000, which is really just the same thing as moving the decimal place 3 places, because our numbers are in base 10. So how many liters is 3,565 milliliters? Well, remember, it's KHD, keep her dancing, because dancing creates marriages. So we're talking about milli. That's the smaller one, M. There's only one M here. So this is this smaller one. This was 10 to the negative 3, which is basically 1 over 1,000. All right, so 10 to the negative 3 is 1 over 1,000. It's 1,000th of it. So what that really means is, whatever your base unit, there's 1,000 of those milli whatever. So if it's a liter, then 1 liter is 1,000 milliliters. All right, so we'll kind of look at that in a minute. So we're wanting to convert from milliliters, so we've got 3,565 milliliters, which would be ml. And again, I like to draw this, so that's what we're starting with. Remember, we're multiplying if it's going to be on top, dividing if it's on the bottom. So we're trying to get rid of milliliters, and we want to end up in liters, because how many liters is what we want. So that's going to effectively cancel milliliters. So how many milliliters are in a liter? Well, 1 liter is 1,000 milliliters. So that's what this tells us here. That's basically like multiplying by 10 to the negative 3. That's the same thing we could have done, but I'll show you that in just a moment. So when it's on the bottom, we divide. So if we do 3,565 divided by 1,000, we're canceling these milliliters. And so that's going to be 3.565 liters. Now again, that would have been the same thing as doing 3,565 times 10 to the negative 3. That's also going to give me 3.565 liters. But it's also just the same thing as 3,565. And in this case, the decimal's at the end. We just don't write it. And it's negative 3, so we go 3 spaces back. And so that means that this is in milliliters. This is 3.565 liters. All right. So let's look at some word problems. So we've got Caroline and Ayana. They're working on a chemistry experiment together and must perform calculations using measurements taken during the experiment. Due to miscommunication, Caroline took measurements in centigrams and Ayana used milligrams. So we want to convert Caroline's measures to 125 centigrams, and so we've got took measurements in centigrams, so convert Caroline's 125 centigrams to milligrams. All right. So let's get my pen back. So we've got 125 centigrams, which is honestly an odd unit. It's not one that is typically used. It's usually either grams or milligrams, but so you can take it in centigrams. So we're going from centi to milli. So let's again just refresh our memory. So that's our units. So we're going from centi to milli. So what this tells me, this one jump to the right, is that there are 10 milligrams in a centigram. In other words, 1 centa, anything, in this case gram, is equal to 10 milligrams. So if I put that over here, we've got 1 centigram is 10 milligrams. And so since we're multiplying when it's on top and dividing on the bottom, this is just going to be 1,250 milligrams. And so that would be the conversion. And that's the same thing, again, as 125 centigrams. But if you're going to milligrams with the decimal here, because it's 1 to the right, we move the decimal one place to the right, and that gives us 1,250 milligrams. So either way you slice it, you're getting 1,250. So what about volume? So a bottle contains 500 milligrams of juice. If the juice is packaged in 24 bottle cases, how many liters of juice does it contain? So you may need a little, more math here as far as, so we've got 24 bottle cases, so 24 500 milliliter bottles. So that's going to be 24 times 500. So 24 times 500 milliliters is going to give us oops, sorry. Get rid of that comma. So it's going to give us 12,000 milliliters. And so we're wanting to know how many liters of juice does this have. So going from milli to, so that's, we're talking about base, deci, centi, milli. So we're going from milli to the base unit. So that's really just 3 jumps to the left. So starting here at the end, 1, 2, 3 is what we're going to jump to. So what we're talking about in this conversion, going from 12,000 milliliters to 12 liters. So this case of 24 bottle juices contains 12 liters of a juice in this case. So again, using that trick is kind of nice. Again, I really like looking at the table. I think it's a little more visual. So just for completion, I would like to show you that. So we've got, we want milliliters down here. We want to end in liters. So 1 liter is 1,000 milliliters. So if you divide, because it's in the bottom, then milliliters cancel. And one good thing about this is that's basically canceling those 3 zeros, which is how we, again, get the equivalent of 12 liters. Because liters, you see, is the only unit that survives. All right, let's look at one final example, and we'll call it a a success on this video. So the nutrition label on a jar of spaghetti sauce indicates that one serving contains 410 milligrams of sodium. So we've got 410 milligrams of sodium. And you've poured 2 servings over your favorite pasta before recalling your doctor's advice about keeping your sodium consumption to 1 gram per meal. Have you followed your doctor's recommendation? So if we've got 410 milligrams, so 410 milligrams, and we're going to multiply that by 2 servings. This is actually 410 milligrams per serving. Right? So what happens is 410 milligrams per serving times 2 servings. You can kind of see these servings cancel. And so what you have is 820 milligrams. So you have 820 milligrams. And so to convert that to just grams, because milli is the last one, it's -3. That's going to be 3 to the left. 1, 2, 3. So that is 0.820 grams, which is less than 1 gram. So as long as nothing else in your meal had any other sodium in it, then you are underneath your doctor's recommendation. But if something else has some more, salt in it, then you're looking at potentially going over. So, all right. So it is your turn. It's time to practice. Watching this video is great, and I hope you took some notes, but math is not a spectator sport. You have to do it yourself. So read section 9.1 of the metric system if you haven't already. There are problems in there called Your Turn problems. The answers are at the end of the section for you to check your answer. So try those problems and see if you have mastered this. And then once you've done that, head on over to your LMS and complete the associated homework assignments for this section. I look forward to seeing you in the next video.